Okay, today we have a linear function review. Some of this will seem familiar. It's just maybe it looks a little different than how we've presented it in the past. So this first problem wants me to graph, and it wants me to make a table of values. So if I'm ever given an equation, I'm going to graph first. So if I'm ever given an equation, I'm going to graph first. So as long as my equation's in slope-intercept form, I know what my slope is and I know what my y-intercept is. I know this is going to be a diagonal line because of the x and y. So first thing I always want to plot is the y-intercept. So which of these numbers is the y-intercept? -1. So I'm going to begin by plotting my y-intercept. Remember, y-intercepts always go on the y-axis. So I'm going to plot -1 on my y-axis. Now I'm going to use my slope to move. So my slope is what? -2/3. So slope is rise over run or fall over run. So this -2 is telling me to fall, and this 3 is telling me to go right. So from my point over here, my y-intercept, I'm going to go down 2, right 3, put a new one, down 2, right 3, put a new one, down 2, right 3, put a new one. I want to go backwards too. So what's opposite of down 2 and right 3? Up 2 and left 3. Up 2 and left 3. Up 2 and left 3. And now I've got lots of points, so I can connect myself a really nice looking line. So now I'm going to use my line to fill in my table. So when the x coordinate's -6, what's the y? So I'm going to go left to where my x is -6, and what's my y? 3. Here my y coordinate's a 1, so I'm going to go up to where my y is a 1, and what's my x? A -3. Here my y coordinate's a -1, so if I go down 1, what's my x right there? 0. If my x coordinate's 3, I'm going to go right 3, and what's my y value? -3. If my x value is 6, so let me go right 6, what's my y value? -5. So, if we're ever given an equation, the easiest thing to do is graph the line first, and then once you have your line, use the points on the line to complete the table. So I'm just going to say graph first, complete table second. Okay, this next one gives me a table to begin with, and this wants me to graph and write the equation of the line. Okay, so if I'm given a table, the first thing I'm going to do is plot all these points. So first thing I want to do is plot my points. So if I want to plot -3, 5, that means go left 3 and up 5. If I want to plot -1, 3, that means go left 1 and up 3. If I want to plot 0, 2, I don't go right, I don't go left, I just go up 2. And if I want to plot 3, -1, I go right 3 and down 1. And then I can connect my points and make myself a nice diagonal line. So now I can easily write the equation just by looking at the picture here. So that's the second thing I'm going to do, is write the equation by looking at the graph. And then I'm going to show you another way that you could do it. So I'm going to write the equation by looking at the graph. Okay, so remember, every diagonal line has an x and a y in it. So I want to put this equation in slope-intercept form. I only need to know two things in order to do that, my m and my b. So what is my slope? To get from here to here, I'm down 2, right 2, down 2, right 2. What does that reduce to be? -1. And you can see here it went down 1, right 1. So you can see the -1. From here to here, it went down 3, right 3, down 3, right 3. That's also -1 when you reduce. So -1 is my slope, so that goes in place of the m. I recopy the x equals and y. And then b is the y-intercept. So where does this line cross the y-axis? add a positive 2. Wherever the line crosses the y-axis, that's your y-intercept, and it's a positive 2. Now, I do want to show you another way to write the equation of the line if we never had a graph, because sometimes it's a pain to make a graph. Sometimes you don't have graph paper handy. So I just want to remind you how you can write an equation of a line from a table. So if I wanted to do this, first I would ask myself, how do you get from negative 3 to negative 1? Up 2. How do you get from negative 1 to 0? Up 1. How do you get from 0 to 3? Up 3. For the y's, how do you get from 5 to 3? Down 2. How do you get from 3 to 2? Down 1. How do you get from 2 to negative 1? Down 3. Remember, when you're finding slope from a table, it's the change in your y over the change in your x. So if I take the change in my y, negative 2 over positive 2, that will reduce to negative 1, which is what I found from the picture of the graph. If I take negative 1 divided by positive 1, that's also a negative 1. If I take negative 3 divided by positive 3, that's also a negative 1. So I know my slope's negative 1 just by doing the change in y over change in x. And then remember, b is the y-intercept. So when you're looking for intercepts, remember you're always looking for zeros. So right here, I know this is an intercept. And remember, when the x-coordinate is 0, that right there is a y-intercept. So I know just by looking at the table that my y-intercept's a positive 2, so I could just write 2. So it's easier to write an equation from a line by counting your slope and seeing where it crosses the y-axis, but we can write an equation from a table too. Okay, let's flip our paper over. We have a little bit of review here. So number 3, I want to solve this equation for x. So a while back we talked about if we ever have a fraction smushed up against a variable, how do we get rid of that fraction? We multiply by the reciprocal. And what's the reciprocal? 3 over 2. And if I multiply this side by 3 over 2, I need to multiply this side by 3 over 2. So this over here makes 6 over 6, and 6 over 6 is just 1. So all I'm left with is 1x. I just don't have to write the 1. So basically, the 3's go away, the 2's go away, just leaving x. I am going to pop my negative 10 over a 1. And when you multiply fractions, you just go straight across, straight across. So negative 10 times 3 makes negative 30. Denominators, 1 times 2 makes 2. And I can reduce that. How much is negative 30 divided by 2? Negative 15. So just a little review of how you make a fraction go away. Multiply by its reciprocal. Okay, number 4 is a special kind of fraction problem. If we ever have one fraction equaling another fraction, what do we call that? Talked about it just the other day. This is called a proportion. And we solve proportions by doing what? By cross multiplying and dividing. So first I'm going to multiply this diagonal. So I'm going to take 3 times x minus 2. I have to put x minus 2 in parentheses, or otherwise the 3 won't get multiplied with all of it. When I go to multiply my other diagonal, I'm taking 5 times 2x plus 3. So we need to make sure we put 2x plus 3 in the parentheses. Okay, from here I know if I ever have parentheses, I need to get rid of them by distributing. So how much is 3 times x? 3x. How much is 3 times negative 2? Negative 6. On the right side, I'm going to distribute my 5. So how much is 5 times 2x? 10x. How much is 5 times 3? 15. Okay, the next thing I want to look for is like terms on either the left side or the right side of the equals. Any like terms on the left side? Nope. Any like terms on the right side? No. But I do see that I have x's on opposite sides of the equals. When they're on opposite sides of the equals, I need to move one. So I like to move my smaller one, so I'm going to move the 3x. So since it's a positive 3x, I want to make it go away. I want to make it 0. How do I do that? I subtract it. And if I subtract it from one side of the equation, I have to subtract it from the other. This way, 3x minus 3x is 0. That's gone. Bring down your negative 6. Bring down your equals. 10x minus 3x makes 7x. Bring down your plus 15. So now that I only have one x, I'm going to circle everything smushed with it. Whatever's outside my circle, I add or subtract. So I subtract 15 from both sides. The 7x drops, the equals drops. How much is negative 6 minus 15? Negative 21. And then I undo multiplication with division, so I divide both sides by 7, and the answer is negative 3. And that's all for today, folks. Thank you much.